Okay, I'm going to be explaining how to get math from other math. Very clear. So, in order to get our potential energy equation, I start off with the potential energy equation given. So that's going to be the potential energy equals 1/2 k x squared, and then I'm going to just plug the x that we were given, which is x equals a cosine of the angular frequency times the time plus phi. So I will just plug that in there, and then I'll distribute the square, and that will get us with potential energy is equal to 1/2 k amplitude squared cosine squared of angular frequency times time plus phi, which is what we're trying to get. So we won that one. The next one is the kinetic energy one, and this one stumped me a little bit, but then I got it, so that's good. So we start off with our given, which is the kinetic energy is equal to 1/2 the mass times the velocity squared, and then we put the velocity equation we were given into that, which was the negative angular frequency times the amplitude times sine of the angular frequency times the time plus phi. So we plug that into the first one, and we get 1/2 mass times negative angular frequency amplitude sine of angular frequency times time plus phi, and all of that squared. And then when we distribute the square, we get 1/2 mass times angular frequency squared times amplitude squared times sine squared of angular frequency times time plus phi. Then we use the equation angular frequency squared equals k over mass, and we substitute that in for our angular frequency squared, and then we will take the mass from the top and the bottom of the equation, and we will simplify. And so at the end of that, we will get kinetic energy is equal to 1/2 k times amplitude squared times sine squared of angular frequency times time plus phi, or that middle one if you can see it, which is great. The last one we need to do is energy is equal to potential energy plus kinetic energy, which is equal to 1/2 k amplitude squared. So we start off by substituting both of the previous equations, the results, into this. So the potential energy equals 1/2 k amplitude squared cosine squared of angular frequency times time plus phi, and the kinetic energy equals 1/2 k amplitude squared sine squared of angular frequency times time plus phi. And then we will add those together, which will equal 1/2 k amplitude squared, and then cosine squared of angular frequency times time plus phi, plus sine squared of angular frequency times time plus phi. And cosine squared plus sine squared equals 1, which means we basically get rid of the entire end part and just end up with energy is equal to 1/2 k times amplitude squared. And that is shown right here. And that should give all of the equations that we need. So yay!